done yesterday and last week. And then today we will do another module, knowledge representation. So okay. Is it really recorded? Okay. In this semester, I think you will learn a lot about data mining and also other classes. I'm spending a lot more time on bringing more advanced technologies to class. So some of you may not like if you do not want to learn more, but I wish you all need somehow the new technologies. Okay, in this class we're not going to use the tools much. Okay. You may learn the tools from anywhere. You can learn it by yourself also. I trust you guys having such capabilities and ability, so you can learn it. But instead, how can we do a little bit of implementation, do more better? Okay. That's what I'm doing these days. I'm doing a lot of programming right now. Python or all for this class, and another class that I am teaching. I have two more the tech intensive courses. Another one is Linux for undergraduate course. Another one is a wireless network. There we do Python and C programming. Okay, so a lot of Python in all cases, right, Evans?
Yep.
Okay. Knowledge representation. Given the world, the issue is how to express the general fact or beliefs so that anything that we can learn or anything that we can describe needs to be written in a specific language, so that next time when the new situation takes place, then you can apply the facts and beliefs, okay, and determines what else we should believe and should not believe. Situation is this: given we all understand visually what that means, okay, boxes on top of another, and of course each box has different color, and all of a sudden you understand all of that, right? Is it the same possible in computer? Not necessarily, right? These days the computer becomes more intelligent, but everything should be taken care of by some types of programmers or knowledge engineers who can provide well-written knowledge, belief, okay, or the facts. So in this case, givens are the red box being above the blue block, and the green box above the red block. And more. You can describe more and more. We all know human can interpret so much knowledge from visualization. But computer can understand very easily if we represent it like that. Red block, open parenthesis and close parenthesis. For example, like this. I want you to get familiar with this type of notation. There is no formal notation. It is fully up to you. For example, if I say on, this is a function, so I can say red block, on, blue block. This is completely represented for that fact, right? It is up to you. And if you can figure out this type of a function, okay, this is a function, right? I need to be very careful. If I say like this, then it looks like R code. Those who understand already, right? So that's the comment, pound sign. This is a function. Okay? Function on. So if you can define function on in Python, then that will be your program. New assignment was on posted or still not? I don't remember. New assignment is that,
the Python assignment, you mean?
Yeah. Is it on
It's
already?
on, yeah.
Oh, okay. If you, those who read, have you read the new assignments? Okay. Anybody who read it once, then there may be some parent function, right? Right? Parent and, for example, Bob and Bobson. I don't know. There's a name Bobson. Maybe David and Davidson. What does this mean? The parent of a Bobson is Bob, right? We can describe it like that. Okay. Parent of John. Parent of Johnson is John. Not necessarily. Maybe Johnny. Something like that, right? Parent. That type of functions or fact, actually this is the fact.
So it's like a Boolean, like true or false sort of thing?
That's a good question. Yeah. Depending upon the fact base that you have, if you ask this, then it may return true or false, like a predicate calculus, right? You're going too far.
Okay.
We are not that smart yet. Very similarly, if you look at this given fact, then you can think of, oh, there may be a function called on, which may take two arguments. First one is any object on top. Second one, the bottom of that. So that you can describe more and more, right? And then next fact is that green block is above red block. So G, comma, red, right? So this is also a function. So if you describe this in a Python, and can Python infer? The green block is above blue block. green block is above red block, which is above blue block. Therefore, green block is above blue block, right? That we understand. See here, green block is above red block, and red block is above blue block. So green block is above blue block. We all understand very quickly, right? So, next assignment is for you to try to build this type of inference using parent function. Parent A of A, comma B, parent B, comma C, parent C, comma D. You list them all. Then finally you can say, who are my ancestors? Who are my descendants? Can I have all from my database? Right? Assuming that my database is closed to world. That is the complete set. So within that complete set, you can apply the inference rule to produce. We call that deduce. We can deduce the new fact. Those new facts are not given from the fact base as is. Fact base gives you only parent notation, one pairwise. But if you link pairwise the relations, then you can deduce more and more and more, right? That is a rule deduction mechanism. So that type of things is given for you to do the next homework assignments.
Do you want us to write out sentences, or do you want us to do formulas? Please say sentences.
That's your interpretation. You can produce a sentence if you like.
Well, I'm saying, would you like us to do?
But simply the list will be perfect. For example, who is Bobson's parent? Then simply Bob. Okay. There are many ways that you can answer, but the easiest way that I exemplified on the homework assignments, that is perfect. You can do more. As Evans said, I'm going to expect some creative way from Evans because he raised that issues. So make some creative ways. That is
using Python.
Yeah, using Python.
Does it matter if it's 2 or 3, or would you prefer 3? Or just
we are going to do that Python today. So don't worry about too much. Those who do not know Python at all, right? I'm not going to push you under the cliff and hey, climb up. Do you have any rope? Oh no, there's no rope. Do your best. I'm not that type of person. Okay. Okay. This is a very simple fact that you can deduce, right? From these two, you can deduce further. This is very reasonable and easy and more. It's not really mechanical, but almost. So your program, as far as you do simple programs, can do. Next ones. This is real tough, right? Knowing these facts and deducing another facts. Can we say it is a tower? That is a big problem, right? How do you know that which one is tower? So that's a lot of, big gap. But with something that you could have, these three, okay? And also, from somewhere, if you learn what the tower is, right? Something about tower, then you can understand. Your inference engine may be able to deduce something new. Okay? Something based upon the concept that inference engine already learned, now apply. From the tower of the architecture, can understand the toy. Knowing toy domain can apply that to galaxy domain, for example. Okay? Knowing criminology domain, then you can understand some terrorism domain as well. Okay? So another thing is this, if it is sunny today, then sun shines on the screen. If the sun shines on the screen, the blinds are brought down. Right now, the blinds are not down. So what is the weather today? It doesn't say cloudy. Not sunshine, right? At least we know it is not sunshine. You're too smart. If it is not sunshine, then you already know that, oh, cloudy. Or so many things that you can think.
Oh, nighttime.
Oh yeah, nighttime. Oh, let's go to bed. Well, let's play a game, which my parents really hate while they are sleeping.
It's like logic problems, like if this, then that.
Yeah, that's,
Like modus ponens.
yeah, exactly. So, let's take a look at another example, like autonomous car, or driverless car, or drones. Drones, aircrafts. Someone asked, is it automated? Yes, but autonomous cars are more than automatic. Is that? What features? Because it self-governs. It governs, right? It has some controls. And good performance under significant uncertainties, like a human driver sits on driver's seat. And also compensates for the system failure. Then we can say maybe autonomous. Autonomous car, autonomous aircrafts. That looks fine. We are all interested in. We have been waiting for such cars. When you get older, you don't want to drive. I do not want to drive. I don't want to get more speed tickets. If it is autonomous, then if anything wrong, then hey, charge it to Google. Uber. It's nothing to do with me. Okay. So here, the last bullet. Now, are those Uber cars autonomous or automated? The challenge to you is the two words, autonomous or automated. How can you differentiate autonomous, automatic, or autonomous? Uber car. You all know where Uber car is now developing and testing. I mean, driverless Uber car. Pittsburgh, Pennsylvania. That project is led by Carnegie Mellon University, and they are developing autonomous Uber car. I think you've seen some news from some channels, right? The road condition in Pittsburgh is even worse than normal average U.S. road conditions. So it is a perfect environment, and also the team at Carnegie Mellon can do. Autonomous and automatics. It's a little different. They look similar, but you want to say something?
Autonomous makes decisions. It's usually right. And automated, it can only do.
That is the opposite, right? If there is something to make decision, that is automatic. So in some situation, automatically. So decision mechanism already implemented, then that's what we say automatic car. It's not a shift mechanism, automatic or manual, but the car whole autonomous is something all the situations given and governing only, not. It's not really decision making implemented. For example, Uber cars doesn't do like it as it drives. It doesn't do if there is some passenger waving hands. It doesn't stop, and it doesn't ask, "Oh, where we want to go," and then from that point it set the destination and go. It is not yet an Uber car. Uber cars origin and destination given. And from origin to destination, all the GPS routing given. In that situation, it drives. Furthermore, Uber car doesn't do like this. If somebody is waving the car, hey, taxi, then stops and where we want to go? He says, Dobbs Ferry. I'm sorry, I'm not going to Dobbs Ferry. Uber car doesn't do that. Well, anyway, how things can know, if not 100% self-learning, there should be something to learn and know. Of course, there is no such a situation that we can learn 100%. Only we can apply because I know 100%. It's not the case, right? We all do. If you make 100 points from, for example, IASP 520 exam, it doesn't mean that you got 100 points because you knew before, right? You know something, and at the examination, you apply and applying inference and deduction, abduction, and all kinds of learning method applied, and finally you made it correct, although you never known before, right? That is the exam, many cases. That is the problem solving, many cases. This slide explains that you know something, right? You will know something more because it is not 100% self-learning. So what you know or what you will know will be much more than what you learn, how will you be able to know more based upon limited knowledge that you have? If you have very, very efficient knowledge representation, so that you have the knowledge, although it is limited, but it is very efficient, very effective, so that under some situation you can activate it more efficiently, effectively, so that you know much more than what you've known before. Right? What you knew before. Here's the case. What is this? That animal. Is it a tiger or a puppy? Puppy. Everybody says a puppy. Or cub? Chicago cub? If this guy asks to computer, then computer has some knowledge, right? Computer might have some knowledge about the color and shape. Then probably computer quickly say, "Oh, there is a tiger," right? But that's not all. How do you know that that is not a tiger? Can anyone say why this is not tiger? Bob, William.
Well, it goes woof woof, not meow meow.
Didn't say anything.
Okay, I'll take a shot. You look at it.
Can you say why this is not a tiger?
Okay, stop rushing. Okay, well, dogs eat it now. Cats are always cool.
Tiger, isn't it? It's like that.
Tigers are like
Is I mean, let me ask you, is it the reason that you immediately say that is not the tiger?
Oh yeah, because which way it comes from. So,
Wow. Okay, that is a good reason. Okay. Any other?
Face.
Yeah, right, face. It's not typical tiger face, right? So, for example, face. If you say face, oh, face. How can you describe tiger face?
More pushed in, doesn't have.
In general, can you describe a tiger's face, which is apparently different from fishy face? This is very similar, but fishy face is quite different. Still, it is not easy.
I would say tiger face is more fearful.
How can you describe fearful? In language, we're talking about in writing. Well, if you say F-E-A-R, F-U-L, then computer understand. Oh, scared.
Like mean face, you know what I mean? Like It looks like a puppy.
Yeah, right. We all know that. How?
Because they taught me that's what a puppy looked like when I was a kid. He looks like a puppy, look at his face.
So you came up to the face, right? Face description.
I mean, you can also go with the tail.
Yeah.
It's a short,
Tail. Yeah,
short,
tail.
stubby little tail. Tigers
Yeah.
have a long tail.
Tail also,
Can
yeah.
you cut it? Sure. Oh, sure. Stubby have to cut it. But going off the face, tigers have a more overall round-shaped face. The puppy kind of goes long, short half circle, and then it goes out to the snout. Tiger kind of looks like someone's punching
Big hair.
the snout
Yeah,
out of the
that
face.
also. Yeah.
If we're getting technical, tigers are larger than that.
Well, this is an image. We can, we can make it bigger. I know what you mean.
Yeah.
Some ratio, right?
It's the
Ratio,
yeah,
like a
it's
leg
exactly.
length and body length. Tigers is more, I mean, it looks very heavy and tight muscle.
But that's just tiger, not cub.
Right.
Right.
But how do you know it's not? It doesn't mean cub.
Because it doesn't say it. It's unambiguous. It's supposed to be unambiguous, right? So if it's not explicitly stated,
Right.
it has to.
The point here is this. 99% of human can understand it quick, right? Even if I said it, hey, this is a tiger, be scared. But no one, right? Everybody's like, computer, very hard to identify that is a tiger, that is a puppy. So, there's a lot of issues. Expressiveness. Anything that you can feel, you can think, you can describe, should be expressed. For example, fearful is really expressed. Very hard, right? Or unambiguous. Evans expressed that very nicely. For example, size of a tail. Some doggies' tails, I think, yeah.
Spread your arms, spread
Yeah.
on the face kind of long.
Right. And flexible. Flexible means if I give you that, if your mission is to distinguish between tigers and puppy, then you may be able to describe in more clever way and effective expression. But is it flexible? Therefore, you can also distinguish it from somebody. Some human might have some tiger face, right? There's some funny pictures. If you find out the image.google.com, then there's tiger-like face. Then there are a lot of such things. Or can you differentiate tigers from something else? Okay. If you show only the face only, then tiger and bat. Have you seen bat face? Not Batman's. Batman looks handsome, but bat looks ugly. Or there's one. Lion and tiger looks similar if lion has haircuts. But anyway, this is a language, and if we have good language, good knowledge basis, then we can think of inference procedures, inference engines. Inference should be correct based on known facts. Your inference engine your inference engine gives you a new fact. That new fact should be correct, likely, right? And also it should be complete and efficient. There are so many other factors available. So what is the language that we can describe? There are many, right? You can use natural language. If you use natural language, then language itself, there is no way that you can make inference engine. Python, there's a programming language. So programming language, therefore you can represent some fact. But Python itself does not provide you built-in inference engine. But you can make it, right? Then your program will become intelligent. It's not just your program is not just given numbers and compute and return result. There's no intelligence there. In this class, given facts, can you return something that we never known before, although that existed in that base, but that knowledge base never described that. So we want to describe such things. Some logic language may be able to do that, but in these days, we do not use a logic language. Logic language that, anybody know any logic language? Used quite widely, and it produced a more strong result until 15 or 20 years ago. It was so popular in 1980s, 90s. Never more 21st century. The language is called Prolog. Anybody heard of that? It's a good name, but stands for Programming in Logic. Okay? Right. Or Lisp.
Yes.
So Lisp programming. LIS from Lisp, P for programming. And now Python. Python is the language can handle Lisp a lot more powerfully and effectively than a few other good languages like C or Java. Okay, so in Python, by writing short sentences, short statements, you can have similar output as a Lisp can produce. So there is no need to use Lisp. Okay, Python is good. So that is the first step, that you can use Python to do similarly in a Lisp language. It's given your second homework assignments. So please try to that. And logic has a language and inference engine we already looked at. And I'm going to do fast so that we may have more time on Python. Those who never known before the Python, okay. I know some of you already know. Raise your hand if you know Python already. Wait, didn't you? You took my. Oh, you are now taking? Or you guys taking? You took, right?
No, I just have picked up.
Oh, so no one's took 505 from me?
I can't handle it.
You took it online. Stephanie, you took it online, right? Oh, with me? Oh.
Yeah, it's one of the things that if you're not practicing, you're not going to remember.
Like I knew it when I was in it, now I was on it.
Okay. Okay. That's fine. Let's move. Let's cover this material quick, and then we can go back to Python, and I'm going to explain how Python can do the material that we could learn here. Propositional logic. I know you've taken, you know that terminology in discrete structures. If you took, if you studied computer-related courses, or math, or similar to that, propositions. What is a proposition?
A statement, right?
Yeah, this is statements. Can produce always true? Yes, no.
No.
No. Yeah. As far as it can be determined true or false, then that is a proposition, right? If you cannot determine, then that is not, right? That's a different issue. But it should be determined by for example, I'm so hungry. Propositional. Then it returns true or false, right? Or more specifically, are you hungry right now?
Yeah.
Then more clearly you can say yes or no, right? More clearly, are you really, really hungry right now? Then you can say, is it really, really? If it is not, you can say no. If it is the case, you can say yes, right? So that is a proposition. Propositions. So each one of these can be P, Q, R. So P, it is raining. Q, neither did Jack eat nor did he drink. So this is another propositional logic. But there is some connection. This is a simple statement. This one is the combination of two statements. Jack eats, he drinks, but also it says negation, right? So combine two statements and then negate.
So Jack is probably dead because he never ate or drank.
So we call that compound proposition. Or some other cases you may use. You can combine these two things. This is proposition. This is proposition. You can combine this using or notation. In logic, this is or notation. In English, yeah, there is no or. So the first sentence is Q, and the second one is P, and second one is Q.
So Jack eating is bound to it raining or not?
Maybe some situation, right? Unless otherwise you go out,
Yeah.
picnic. Okay.
Either it's raining or Jack's not eating.
Barbecue.
Oh, sweet.
Barbecue.
Why is this bad?
Oh God, I did not miss this. This is the last semester of college for me. I did not miss this.
Well, this is a prerequisite in our undergrad, isn't it?
Yeah. Negation. In logic, we use this notation. In English and in Python, we use this. Yeah, I like Python, right? It's like English like. In logic, and or, like a conjunctor or disjunctor. In English, and or like this. Python, yes, Python use that English conjunct.
Don't you really have to use symbols in Python, like the two bars and the ampersand?
That is understandable, but that is not only. Yeah, this is exclusive or. In Python, in any language, it does not have that type of simple. But in Python, exclusive or is this. Sorry. Is it carrot? Is it called a carrot?
It's a carrot, yeah.
This is exclusive or. X or. We're not going to do much X or, but wireless communication, wireless network and security course, 560, use a lot of exclusive OR. The beauty of exclusive OR is, anyone? No, you will know.
If not me, is that what it is? Or am I confusing something else?
Exclusive OR. It returns true only they are different.
Oh, okay. That took me a second. Yeah.
As far as they are the same, then returns false.
Okay. That's pretty cool.
And further, negation of conjunction, negation of disjunction, implication. If you say if then, in Python we have if, right? If some condition and semicolon, and then you can do action. There is no then. In Python, describes if and P followed by colon, therefore it understands then. Instead of the then, in Python, we put colon. Right? That is something that Python is not really natural language, right? That is anyway programming language. So it should be simple in a way. So instead of then, THEN, in the programming syntax, we put colon. Okay, so this is P and here Q. If we have here else, P, Q, all, if P then Q else R, then that is written in Python. We say else, and then colon, and R. All right? In logic, this notation is not really standard, okay? But at least we all agree. Then we can use arrow, right? If P, then Q, like this. So I wanted to follow that notation throughout this class. P, right arrow, Q, then in handwriting, not in programming language. In programming language that I already talked about. P implies Q can be rewritten in disjunction like this. They are the same. Exactly the same, but only different view. P arrows Q is more proof theoretic notation, which means to evaluate that implication, we always pick up P first. If P true, then we pick up Q. If P is not true, then forget about it. Forget the rest. That is what we do, right? So that is proof theoretic notation. It's called proof. This is a model. It's a model theoretic notation. What it means, I have a situation, P is not true, Q is something. Then all such models returns, all such models are the model that can be covered by this implication. There's a model theoretic notation. By having this, you can describe, oh, we might have this kind of models that can be covered by that implication. There's no other models. Based upon the model, then you can have a real situation, right? That's a model. Okay. Let's pass. Another thing, modest ponens. How can you get, let's say you have this inference. This is a rule, right? Rules available from inference engine, but in our case, that is your program. Your program implemented P implies Q somehow. And P is given. This is just given. Like parent, remember the first slide of today's? It's given. Parent, John, Johnson. Then there is a factor such that the parenthood, for example, John is the parent of Johnny. That type of things. There is a fact. Yet there is no implication. Implication is this. If Johnny married, therefore Johnny has his own son, then John is a grandparent of the son of Johnny. Son of Johnny is represented in the way that we know parent, open parenthesis, Johnny, comma, something else. Ellen, close parenthesis. Then John is the grandparent of Ellen. That is the consequence. This is generated. Okay. Again, parent. Let's say parent, John and Johnny. That is a fact. And then the rule says parent X, Y, and parent Y, Z, then grandparent to Z is X. Right? This is a rule. Say parent, John is a parent of Johnny, and another fact given, Johnny is the parent of Ellen. So what is the consequence that I can have? if there is this rule, and if y and that y is the same, then x is the grandparent to z, right? So right now, this John here and that John there, they are the same. Therefore, the consequence that we might have is John is the grandparent, G Paul is Anna. So these facts antecedent can be given. You simply write it. And you need to implement this. This is programming. And run, then it should reduce this kind of new consequence. Okay? That is the homework assignments. So now let's make your program a little bit intelligent. Okay? Models tolerance and all others, I'm going to skip that. You may be hating me, so okay. Practice in Python. All right? So we will do this after break. But for those who do not have a Python, raise your hand if you do not have a Python installed on your system. Yeah, right now, before you go out, you have to install the following.
Do you need to install Python though, or can't you just use any programming?
Oh, yeah.
This is a website.
Yeah, download Paizo. Paizo is better. Okay. Download. www.google.com. You can say Paizo. Download. Paizo is good for this class, for Python, okay? But really good tools that can cook Python is Anaconda.
Oh, Anaconda's awesome.
Have you seen Anaconda? What is the Anaconda? That's the biggest snake, right?
It's like Python plus plus, basically.
Exactly. There's a Python plus plus. So Python can be cooked well when it encounter Anaconda. So Anaconda is the best, but we are not going to worry about Anaconda. Okay? Python. Or Python, Paizo, you can download it. One or the other. You can download somewhere here. Sometimes, those who have a Mac, you do not have to worry about. You already have. Windows user, you need to download Python or Paizo. Okay? And then we'll take 15-minute break. All right? See you. All right, assuming that somehow you have a Python interpreter running on your system, your platform, Windows or Mac OS. Paizo is better. But if you, I mean, those who do not know the detour to install Python on Mac, I may try to recall at home. We do not have time right now, right? But I did that. You could do that too. Someone who knows, help them, okay? Because Python yet not really fully trusted by Apple. Not because it is really malicious, but it is new to them.
Is it unsigned or something?
Maybe unsigned, yeah. So, but you can still install it somehow.
Oh, you have to go into the system preferences and click on something in security, I think, right?
Yes.
Oh yeah,
To, like,
yeah,
Mac apps outside of the
yeah.
Mac App Store.
Mac, for at certain points you can allow.
Yeah.
There's some configuration.
Press control, command, and then right click
Yeah,
and open.
find out some way that you can unset and then install it. To do the homework, and not only that, but in general, data mining, we'll do Python and R here in this class. But if you use R, then it is a more statistical approach. Data mining is not just a statistical approach, but it is much more than that. So somehow we can work on R, and at some other cases we will work on Python. Most cases, data structures that we use in Python is a list. What is a list in Python? Stephanie, I know you know Python, so you may be able to answer what is list in Python. You can guess from literal meaning of a list. Oh yeah, perfect. So she knows it well. So anybody who has any question about list, ask her. Because she made a good answer. List is a sequence. It's a not really sequence. Take it back. It's not really a sequence. It's a set of elements. It's not an array. The term used in many programming languages, but you can use like an array, but more flexibly. Okay. This is something like this. In square bracket, within square bracket, you can list some of the elements. And there is a delimiter, comma. Okay? That's it. So data can be populated in this way. So data is ready. How can we form a rule? Rule is nothing but a function in Python. So for example, parents, this is a list, right? Because we have a square bracket, open square bracket and close square bracket. Within this square bracket, we have number of parentheses, right? Within a parenthesis, we have two elements. So we have a parenthesis here, and another here, and another. You can add more and more and more. Okay. While you are doing programming, you can add more and more. Okay, or you can remove. In particular terminology used in Python, we can say append rather than add. So append function and then remove function. Those two functions are highly likely used. And then you can interpret. For example, homo is the parent of Bart. And there is another. Bart is the parent of Jim. And Homer is the parent of Lisa. And Ab is a parent of Homer. So, as you read this, because we are all smart, we quickly can generate some other factors that are not described in this factor base, right? For example, is there some siblings? Yeah, you are smart. What's Jim's grandparents? Is there any grandparents described? Yeah. You're all smart. Can we implement it in Python?
A lot of developed statements.
Right. But this is a homework assignment. I'm not asking you to do all. Oh, this is not homework. This is an exercise. Let's try with the child and grandchild. Okay? In our exercise. For example, child is a function. Suppose that we define the child function. Then we can run child of P. What is P? P already given here. P is nothing but homo. So by having this, we can ask, who are the children to homo? Right? It's so-called siblings. So children is somehow, in the print statements, like Evans mentioned earlier, you can print P has children and children here. This, whatever you have here within double quote, within double quote, you can say whatever you want to do, but it'll be echoed. Okay, whatever you say within double quote or single quote, if you open single quote, you have to end with single quote. If you open double quote, and double quote. Anyway, single quote or double quotes. If you do it, then what is contained in that quote pair will be echoed. Okay? Echoed to where? Echoed to the word air, to the standard output. Standard output. Computer is a standard input and standard output. What do you think is standard input? Computer. What is the input device? What is the standard input device? Keyboard. Therefore, what is the standard output? Monitor, right? Terminal. That is the standard output. Huh?
It's standard IO.h. Let's see.
Oh yeah. So it'll be written on the terminal. What should we do now is the implementation of a child. Implementation of a child is something that you need to do. This child function. Okay. So homework assignments, as I said, I want you to, this is a little challenge. So don't try to do directly, recur means recursive. Those who do not know recursive, don't try to do recursive. I'm sure some of you can do, right? If you, this is real tough, right?
It is not.
You can do it in 1 week. If you can do this in 1 week, you can get a job. Challenge yourself.
If I can do it in a day, what can I do?
No, six-figure positions. If you cannot do, I want you to do parent, like grandparent or grandparent, okay, rather than recursively going all the way up or all the way down, depending upon the size of data. That is, this function is more general, robust function. But before you get to that, I want you to try, as we will do here, child or grandchild. I want you to do parent. Parent is given, right? And grandparent.
Doesn't this really have to be done with recursion? Or is there a way around that?
Recursion is not really something that you cannot avoid.
Okay.
You can do if-then, if-else statements. You can do all the way,
But is
or
there-
while loop also within your function. But recursion is good. It's a good if you have very complicated data structures. Yeah. Okay. So that is that, and all others I'm going to skip. Okay, stick to this. Let me close this card. Okay, right here. What I'm going to do here, those who have Paizo, I want you to open up. Okay. I'm going to. Okay, this is empty. Left panel you have empty. Here, I want to have here clear screen. So we have really clear screen here. And shell is very, very important. You should have triple greater than sign. Therefore, this panel is nothing but the terminal on Windows or Apple. Let me bring up, for example, those who have Windows systems. You can bring up terminal Windows, right? Here, if you install Python, then probably you need to go to, if path is set properly, then you do not need to. But unless otherwise, you need to go to the location where you install Python, like this. And if you type dir, then you can see Python, this file, python.exe. Okay. Find out python.exe. Then you type Python. Enter Python, then you will have this triple greater than sign, which is exactly the same as this greater than sign is the same as that greater than sign. If we type here 3 plus 8, then it returns 11, right? So I'm not going to work on here, but back here. So what we need to do is, let's try this. Parent, equals and I'm going to put list. So parent is a list. I can type it, but for example, parent equal, I can type what? James is the father of Jeremy. And you can do more. For example, David is the father of Davidson. And if you want to close, then you can close. Oops. Couple object. Oh, because I didn't put comma here. After this, I need to make comma. And then keep going. What did I say? David close the parenthesis and square, close square bracket. The beauty of this Pfizer, if you click this open parenthesis, then it automatically marked the close parenthesis so that you can see the pair. So that if you click this, then it's closed. So this is okay, safe. At that point, you can say enter. Then parent is defined, right? So if you type parent, then we can see, oh, parent has two elements, and first elements James, Jeremy, and second Dave and Davidson. If you want to access the first element of that, then we need to put index number 0, then it returns the first element like this. Similarly, if you put number 1, then it will return the second element. See here, this is the first element and this is the second element. If you want to access the first element, then you need to put there 0, the second one 1. If you want to add more, that is also possible. Parent, append, and then you can put, for example, Jeremy is the parent of Johnny. See here, parent is a variable, but this guy already understand, oh, that is the list, therefore we can access the element of the list, and also we can execute the function. We didn't implement the function for parent, but soon as we enter the data, it automatically understands, oh, there is a function that we can use. There is append, so that you can add more and more elements. Append. Sorry. We need to have a tuple. Element of that is a tuple. the outer parenthesis is a function parenthesis. What I want to enter is this whole element. That element itself has two elements within parentheses, so that I have the third element within parentheses. That way, and add it. And then, if I type parents, then I have now three relations, right? Three relations: James, Jeremy, David, and so on and so forth. It is successfully done, then you can copy and paste here. So that later you have to have here equal sign. Okay? So that will be your file. This is simply a command line. What I want to implement here is a child. Okay? So, in order to have something about child, then what do you need to do? You need to compare. For example, pick up one. If there is any name that you want, for example, let's make one more. Let's create one more. For example, James is Jeremy, Jeremy is Johnny, and one more, Jeremy. Jeremy has also single quote. Jeremy has, let's say, Sonny. Okay. So what I want to figure out here is I'm going to implement a child so that I can say, oh, what is child of Jeremy? What I expect from there is, oh, child of Jeremy is Johnny and Sonny, right? That type of things. But we didn't implement that yet. If I do this, then we'll have an error. Okay? Of course, I didn't implement it. So we have to implement it. How can we implement it? Before we implement it, we need to figure out these statements, for loop statements. For x in, say, parent. Let's first find out parents. What we will do, I'm going to copy this. Again, this is back and forth. I can, oops. Yeah, we do not need to make next line. Where is my cursor? Oh, here. So I'm going to, making one line, and then enter. What happens? Syntax illegal. Oh, another one. Open square bracket. Then I have parents. So somehow it is not really properly. Yeah. So everything should be in one line. Make sure that it is on one line, right? It is one line. Yeah. Okay. So we have this, and what I want to practice here with you, for loop, x, for each x in parent, and colon, and enter, then there is an automatic indentation, so don't worry about it. And then we can say print x. And then enter, enter. Enter. Then it returns element of those. This element, that element, and that element, and that element. This statements gives you that result. So if we do the similar one, parent, but print x of 0, the first element of those, enter, enter, then what it returns is that among it, within each parenthesis, I want the first element. James, David, Jeremy, Jeremy. Similarly, I can do for x in parent, print x, but second element. Then what do you expect? Yeah, Jeremy, Davidson, Johnny, and Sonny, right? So a little bit of ways that access the data and also automatic within for loop, like iteration, rather than touch each individual data by saying this for loop statement, iteration, this iteration touches element by element within this parent and access further detailed elements in this way. Remember that the difference? Initially I said print x, and the next one is print square bracket 0, and then square bracket 1. If I say x, then top level element is returned. If I have a further detailed access, therefore having square bracket with the number within it, inside, then depending upon the number, it returns detailed, right? So back here, we can implement. Function is implemented. Let's say child. I can get the child information so that if somebody said, "Oh, who is the child? Who are the child of Jeremy?" This is. Remember, this is my question, right? And then we can put here my question. We can do this. This is. By the way, pound sign is a comment, so that it gives you some comments. So this is the definition of child function. Okay. So how can I make child for the given p? Child here is the function. It has value p, but when this function is executed, Jeremy is copied into that p, and then that is cooked within that. So depending upon the caller, this guy is caller. It's a caller, right? This guy is a caller. Caller. This guy call with the Jeremy. Then Jeremy is copied into P, and then P is Jeremy is cooked within. If I say child David, then David is copied into this child function and cooked further. So I need to play with this P. assuming that, oh, P is somebody's name, therefore I need to search through this parent, right? So as we did in this command line, we need to do for X in parent. And then I need to say, in order to get parents of Jeremy, then what should we do? What should I do? I need to first, if there is a Jeremy on the left side of each parenthesis, right? If Jeremy appears in the left side, not the right hand side, but left hand side, then right hand side will be the child to Jeremy. If I find another Jeremy, then right hand side name is the child to Jeremy. If there are many more parentheses, that way still I can find all the children to Jeremy. So what you need to do here is that I need to see if X, the first element, I need to compare. First element, if it is Jeremy, Jeremy is P, right? Whoever asked for, I want to see if this, whatever requested, appears on the left-hand side of the parentheses. This gives you the left-hand side, right? X gives you parentheses, 0 index gives you left-hand side. If this is the case, then I can say parent, print. I want to print right-hand side. Right? And then save it. I want to save this. Save as a particular, whichever you want to save. I want to save it 520 Python, thank you. And then I can say here child or homework 2. Okay, homework 2. So now homework 2 on tab of this. So I'm going to see how it works. This command line. How can you run? If this is on this panel, then you simply control and enter, then it runs. Oh, Johnny and Sonny. What a great, right? I asked Johnny, who's the child of Jeremy? Look here, who's the child of Jeremy? When I highlight this, it highlights up here, right? Jeremy, one time, is the son of somebody. Jeremy, and another times, parents of somebody. So what it returns is child case only, right? Let's move further. This is printed. Is there any way that I can receive here? So that I want to save this to children. And I want to type print. And also, rather than this, I'm going to say here P equals Jeremy. And I send this Jeremy into that function call, and I'm going to say here P. And then followed by has children, child, singular, plural. And then children. Right now children is the variable that can hold the result of this call, result of this function call. But this function does not return anything. It just prints to the terminal. So instead of or, together with the printing the terminal, can I send it back? In that case, you need to have return. Return what? Return result. Well, what is the result? There's nothing result that we define yet. Then you need to do, okay, result is currently empty, but I want to add that result when it comes to, when I find the x1, I'm going to put that on the result. How can I put that on the result? Remember that append? Right? And I want to add x of that. So this guy result. This guy, every time I want to print this, at the same time, they are the same level, right? If this is true, then I'm going to print and also bookkeeping the result list. When this for loop is done, remember this very nicely, there is some indentation. If indentation done here, for loop done here, when it done all the for loop, therefore I might have the result, then I can return result. Okay? And I want to save this and then hit Control Enter, then you can say Johnny, Sonny, Jeremy has a child, Johnny, Sonny, right? If I change this, for example, someone else, rather than Jeremy, if I say James, and save it, hit Control and Enter, then Jeremy has a child, Jeremy only. I mean, James has Jeremy only, right? If I change this to, for example, David, save it, and then David, look at here, Dave has child Davidson only. So like this, I wanted to create functions, more and more functions. How can you make grandchild? Grandchild. Grandchild can be defined. What time is it? Yeah, we have time. Grandchild. Again, I can bring it P. How can you say the grandchild? It's a two-step, right? Given the name P, you need to find out child first. And then for each child, you need to child again, right? 2 times.
So it's an iterative for loop, I imagine?
Yeah, another for loop within that. See this. First, for this P, you can say, oh, I have children, which is the result of child P. Child P is already installed, right? So I'm going to call child P. Then this is children is a direct child to the given P. Now we need to do for loop. For x in children. To see if it has, again, child. So what I need to do? I want to create result equals empty list. I'm going to put here result append child of P. Grandchild equals grandchild of P. Print P has child and GC grandchild. Rather than David, I'm going to James. If there's an error, then we can fix it. Oh, there's no error right now, right? James has a grandchild, Jeremy. Let's see if it works. James has, no, that's not true. James says Jeremy, so we are expecting Johnny and Sonny, right? So, we have to tweak a little bit. I think there may be some issue here. Yeah. So, here we need to another if. If X is, it returns Davidson, right? If X appears, no, X appears on the first two, a little bit of, I think we need to have another for loop. Yeah. For y in parent. So that if x is children, so we don't have to do that. X is y's parents, then we can do
you just need to use the trial function again, and you can get a child.
yeah. So let's do like this. Yeah. So grandchild has two for loop. The result of a child, which is children. So for each child, I want to go back to the original database and then compare child of P, whether child of P appears in the parents, then child itself is a grandchild. So James James has a grandchild, which was Johnny and Sonny. Okay. This is a simple example.
Simple.
I'm going to post this on the Blackboard so that based upon this, you can practice
Thank you.
and extend for your homework assignments. Remember that instead of child, you need to go back to opposite, parents. And then there's the first thing that you need to do, okay? Parents and grandparents. At least I want you to do that. And then ancestor and descendants. You need to find out full scope. Okay?
Sure.
Any question?
Not a question, but I just know how to access.
Yeah. I'm going to, before I forget, I'm going to post it. Okay.
So I have to try to find out how to bypass this. They said it's pretty easy. I think we have to just go into the applications and
Just for the system preferences and security.
yeah.
No problem.
So I'm going to give you this homework. I'm going to attach the sample, the homework assignments, so that you can download it and practice it. Where's the homework? The homework 2. Okay. So here's the homework. If you download this pw2.py, then that's the code that we practiced today. But do not submit that program as is. If you resubmit it, then you will receive 0. You have to touch. At least you need to show parents and grandparents for partial credits. Okay, so homework assignments has hw2.py. If you click that, then that is downloaded. Can you see it? Yeah, open. Oops.